Good afternoon, dear colleagues. Now I would like to share you some experimental results on generation of runaway electrons during the high voltage nanosecond discharge in strongly inhomogeneous electric field. The results was obtained in laboratory of optical radiations in the Institute of High Current Electronics.
В обратную сторону.
Okay, thank you. Currently, the high voltage nanosecond discharges in atmospheric pressure air is being actively carried out. Such discharges are the sources of non-equilibrium low temperature plasma, and such plasma can be used in different fields for solving of number tasks. This is due to that such plasma object contains different reactive species and ultraviolet radiation. But this report is devoted to runaway electrons, playing an important role in the formation of diffuse discharge in dense gases under conditions of strongly non-uniform distribution of the electric field strength. Okay. And until recent, there were no any methods to correctly study process of generation of runaway electrons with respect to the process of discharge formation, but owing to our recent studies, such method has been found. I'm talking about the next thing. When studying the positive streamer or the dynamics of the positive streamer during high voltage nanosecond discharge, it was found that behind the grounded grid anode, the electromagnetic signal was registered, and this signal is caused by the redistribution of the plasma, which is formed at the breakdown stage, and electric field penetrates behind grid flat anode or cathode and registered with a collector that serves as a detector for runaway electrons in general. And this signal reflects the dynamics of the streamer that provides the breakdown of the discharge gap. I mean the next. Here we can see the start of the streamer that is formed in the gap, its propagation during the or along the gap, and this moment corresponds to the bridging the gap by the streamer with large transverse dimensions. And here we can see backward ionization wave. In addition, here you can see pure displacement current that caused by change in the voltage, and current that we call dynamic displacement current, which is due to the change in the capacity of the discharge gap. So if we can correctly to register signals of runaway electrons and dynamic displacement current simultaneously, we can answer the question when runaway electrons are generated in the gap. So the purpose of this study is to determine the moment of generation of runaway electrons with respect to the discharge formation dynamics. Here you can see the experimental setup, which was consisted from discharge chamber, which was connected to the high voltage generator through a transmission line which contained current or capacity voltage dividers. Signals from capacity voltage dividers registered with real-time digital oscilloscopes, and voltage pulses or voltage across the gap was reconstructed with incident and reflected voltage waves. Discharge gap was formed by needle cathode and grid anode. Using of grid number 1 allowed to us register simultaneously runaway electrons and dynamic displacement current, and by addition of grid number 2 we can register only runaway electrons. To capture images of glow of discharge plasma at the breakdown stage, we use 4-channel ICCD chamber. So here you can see the waveforms of signals which were registered with a collector behind the grid anode in the conditions close to the threshold for breakdown. Here you can see pure displacement current, red curve, displacement current which is implemented in the case when streamer breaches the gap, and displacement current in the case when streamer didn't reach the grid anode. These waveforms indicate that in the case of negative polarity of high voltage electrode, signals of displacement current are registered behind the grid anode, and they can serve for explanation of dynamics of streamer, which provides breakdown of the discharge gap. Here, there is no waveform of electron beam current, I mean runaway electron current, because voltage was too low for generation of such electrons. And when runaway electrons are generated, it will be determined by the location of signal on the time axis. By selecting the transparency of the grid number 2, I mean grid before that was installed before in front of the collector, we can choose conditions when amplitudes of runaway of signals of runaway electrons current and dynamic displacement current were coincided. And here we can see waveforms of the voltage across the gap in the idle mode, in the mode when discharge was occurred, and waveforms of the dynamic displacement current and some of the dynamic displacement current and the current of runaway electrons. Taking into account the fact that energy of runaway electrons and the fact that the velocity is less than velocity of electromagnetic wave, we should signal of runaway electrons to shift to left by 75 picoseconds. Thus, we answer the question that runaway electrons are generated at the stage when a streamer is formed and ionization process starts near the cathode. This generation of runaway electrons occurs near the cathode when streamer is formed. Here you can see the waveform of runaway electrons registered with high bandwidth oscilloscope, and here we can see that its duration, fluid maximum, is about 23 picoseconds. If we decrease air pressure, the phase of the streamer formation and breakdown reduces, but generation of runaway electrons is still observed. More curious effect is observed when air pressure is about 20 kPa, as well as this effect is observed when helium pressure is about atmospheric pressure and at low pressure of sulfur hexafluoride. We can see that after the streamer breaches the gap and backward ionization wave moves towards the cathode, the second pulse of runaway electrons is generated. This pulse has more duration and in some cases has a more higher amplitude. Thus, if second pulse of runaway electrons is registered, we suppose that after the breakdown in the gap there is a zone or area or region with a high electric field, and we believe that this region is formed near the cathode, and this is its next process. When electrons move to the flat anode, near the cathode ions are collected, and when the backward ionization wave arrives to the cathode, there appears a potential drop zone, which is characterized by high electric field strength. And so the electrons which are generated there gain energy from the electric field and can accelerate second time towards the flat electrode. Okay. Having studied this process using the 4-channel ICCD chamber, the fact was found that second generation or second phase of generation of runaway electrons is connected with explosive emission. I mean the next thing. If during the process when streamer propagates along the gap, cathode spot doesn't appear, second phase of generation of runaway electrons is in the case when bright spot or cathode spot, which is due to the explosive emission, appears at the electrode with a small radius of curvature. Generation of second flow beam of runaway electrons doesn't observed. So, summary, it was shown experimentally that by registering simultaneously the displacement current and the runaway electrons with the collector behind the flat anode, we can answer the question when runaway electrons are generated. And for the first time in the experiment was shown that the generation of runaway electrons occurs immediately when a streamer appears in the vicinity of the pointed electron. And it is shown that runaway electrons can be generated after the breakdown of the gap. The generation of runaway electrons occurs in the cathode layer with a sharp increase in the electric field strength due to the arrival of a backward ionization wave in the poised electrode. And the development of explosive emission centers limits the secondary generation of runaway electrons. Thank you for your attention.
Please.
Thank you for the presentation, and I have some question about the measuring of runaway electron current. Yes, it has a very small duration, yes, I saw 20 picoseconds.
Okay.
How did you measure?
Just a moment. We measured runaway electrons behind the grid anode with a collector, current collector, which was connected through a cable with the oscilloscopes with a high bandwidth, about 50 gigahertz.
Okay, collector, metal collector, yeah?
Yeah, metal collector, yeah.
That's
The receiving part of collector had a diameter about 3 or 1 millimeter.
okay, but it should be some shunt, resistor shunt, or some capacitive component.
Shunts that we know didn't allow to register correctly such durations of signals. The resistors that used for shunts has or have small bandwidth or very expensive resistors.
please.
Oh,
There is some runaway electrons avalanche was observed in 2012. It was work by Revising group with the measurement of primary peak, first peak of runaway electrons, and avalanche of larger amplitude, of longer duration. And recently it was also
I know
supported
this paper.
in 2020. Also is a paper with 3 grid systems with acceleration of electrons after second electron. So is it possible to so what do you think about this? Can it be associated with avalanche, with secondary avalanche accelerated in the gap?
This is a complicated question because there are different terms are used for the characterization of this phenomenon. I don't know.
This answer is not very simple. During coffee break, it's possible to discuss.
Okay.
Thank you very much for presentation.
Thank you.